Hi and a very good day. My teammates consist of Alia, Atika, Sufia and myself would like to present on research regarding recent advances in forensic DNA phenotyping of appearance, ancestry and age published by M. Kaiser et al. In April 2023. Externally visible characteristics or EVCs such as appearance, biogeographic ancestry, and age can be predicted from DNA extracted from human biological samples gathered at crime scenes by a process known as forensic DNA phenotyping or FDP. As the sample donor is unknown to the investigation authorities and its short tandem repeat profile or STR profile is unavailable for comparison matching, FDP is used in criminal cases where no match is established in forensic STR profiling. Advances in forensically motivated DNA prediction of appearance traits. At the time, several predictive DNA marker sets, multiplex genotyping tools, and statistical prediction models had become established for making categorical predictions of eye and hair color from crime scene DNA. While it was becoming possible to predict skin color from a person's DNA, it was not possible to predict other appearance attributes from DNA due to severe gaps in the genetic information for these qualities. DNA prediction of skin tone has become more established since 2015, and predictive DNA markers have been discovered for additional appearance attributes such as eyebrow color, freckles, hair structure, hair loss in men, tall height, and grey hair. Crime scene investigation involves gathering clues. When age prediction is added to appearance and heritage, DNA in the FDP ideal becomes much more reasonable. Reasons for this include the fact that a person's age can be used to characterize them, and the fact that the expression of some physical characteristics varies with age, and the fact that for some characteristics, age is employed as a predictor in genetic prediction models. However, only DNA methylation, or known as DNA-M, analysis has proven to be precise enough to give a practical answer for forensic applications, despite the fact that other methods for age prediction have been studied in forensic molecular biology. For the problem statement part, most recent and older research on appearance, ancestry, and age prediction based on DNA have been conducted with forensic purposes in mind, but there are some important considerations that apply to all of them. Firstly, the sample size of the dataset used to discover the predictive DNA marker were frequently tiny in size, which results in uncertainty regarding the predictive value of the markers. Secondly, as the datasets used for building and validating the prediction model were tiny in size, they are not independent from each other. Thirdly, many of the reported prediction models were not made available as prediction instruments, which prevents their implementation in practice. Next, many articles that describe prediction markers and models do not provide a multiplex genotyping instrument, which hinders their practical applications. And lastly, when multiplex genotyping tools were disclosed, they frequently lacked in forensic validation studies, which eventually prevents their use in forensic. The findings from this study can be beneficial to infer the externally visible characteristics, or known as EVCs, of an unknown stain or sample donor from DNA extracted directly from biological material left at the crime scene or obtained from unknown bodies. In essence, FDP outcomes can serve as biological witness and may provide even more precise information than human eyewitnesses. As a result, FDP is anticipated to provide investigative leads that enable the identification of unidentified perpetrators who cannot be identified using conventional comparative DNA profiling. FDP is also anticipated to be useful for identifying missing persons in cases where reference DNA profiles from putative antemortem samples or putative relatives are unavailable. The objectives of this study are to develop new size of predictive DNA marker, to validate the new size of prediction model, and to give more exposure on reported prediction models that were not made available as prediction instruments.
An optimum approach for developing and validating FDP tools includes DNA predictors ascertained from a large dataset not used in prediction modeling. Secondly, a prediction model built in a large independent dataset and validated in a large independent dataset, while the model validation delivers high enough prediction accuracies for appearance and ancestry and low enough error for age. Next, the developed prediction model is made available for practical applications as a prediction tool. Other than that, a single multiplex genotyping tool is developed for all DNA predictors used in the prediction models based on a technology suitable for analyzing low quantity and low quality DNA. The fifth optimum approach is the multiplex genotyping tool has undergone forensic validation and successfully passed the major validation steps. Lastly, the forensically validated multiplex genotyping tool is made available together with the prediction tool, thereby allowing practical FDP applications in forensic casework. However, in reality, many studies did not meet several or all of these points, which limits the FDP applications.
Next is the challenges of DNA prediction.
Early studies have shown that accuracy of age estimated using DNA methylation marker is reduced in elderly, associated with global decreases in the stability of DNA methylation as they grow older. This may be due to the hereditary DNA variants, environmental factors influencing the rate of the DNA progressions, and probabilistic effects that occur randomly. For instance, the development of cancer in tissues. The SNP system requires high quality and high quantity of DNA, which can be difficult to obtain in forensic genetic tests. The quantity of DNA is lower than in general human genetic studies, and forensic DNA samples are often exposed to various environmental factors, including PCR inhibitors, degradation, and contamination by other individuals, animal, plants, and microbial DNA. Biogeographical ancestry tool emphasizes on subpopulation comparison, which does not accurately reflect a forensic DNA donor's ancestry. This means that many of the ancestors of the DNA donor are not represented. For example, on the figure, the male grandchild inherits the Y chromosome from his grandfather through his father. Unfortunately, the female grandchild did not receive Y chromosome since Y chromosome is only inherited from father to son. Thus, it presents a challenge for forensic to determine a complete ancestry from the crime scene DNA sample.
There are several new application techniques for forensic DNA phenotyping that are currently being developed and refined. One such technique is called probabilistic genotyping, which uses complex statistical models to interpret DNA profiles and extract information about an individual's physical traits. Another emerging technique is called molecular photofitting, which combines DNA analysis with facial recognition software to create a visual representation of what an individual may look like based on their DNA profile. Additionally, researchers are exploring the potential of using machine learning algorithms and artificial intelligence to analyze DNA data and predict physical traits with higher accuracy and efficiency. Overall, these new techniques have the potential to significantly advance the field of forensic DNA phenotyping and improve our ability to solve crimes and identify unknown individuals.
I will proceed with the comparison between forensic DNA profiling and short tandem repeat profiling. Both of these DNA profiling are different, but at the same time have the same purpose of finding potential suspects. FTR profiling has been recognizable for such a long time. However, it has inadequacies such as it needs suspects or sample donor to find a cooperative matching. However, FDP can find EVC, which is external visible characteristics, in case there is no sample donor. STR profiling uses autosomal STR as a marker. However, this marker is not efficient to be used in a imbalanced DNA mixture. Therefore, Y chromosomal STR are used instead. But these Y chromosomal have a paternal inheritance characteristic that causes the result to be not as efficient as autosomal STR. However, in FDP, it uses single nucleotide polymorphism, which can develop multiple PCR assay, causing it to be more functional than STR profiling marker. Last but not least, in FDP, degradation index does not influence the result. However, this is different in STR profiling, as degradation index could lead to unsuccessful cooperative matching. In sum, FDP has many potentials to successfully emerge as one of forensic science tools. However, few recommendations should be implemented to achieve these goals. The first one is to increase the population data for AIMS NSP marker used in forensics biogeographical ancestry tools. As you can see in the data provided, the area under receiver, which is AUC, showed between 0.75 to 0.95. This shows that it has high accuracy, which make better marker selection with larger allele differences between different. Second recommendation is by carrying out future research to understand the correlation between lifestyle variables and epigenome modification to gene expression and phenotype. The advantages we can get from this is it will broaden the DNA phenotyping by taking account on aging causes by these variables. This is an example of data from a research to see the epigenome modification causes by smoking. So from this data, we can see that it is promisable. By doing this research, we can improve on FDP. So that's all from me today. Thank you very much.